Hello, this is our second tutorial for week 8 of distance learning. This is solving equations involving distribution, and we're still using sketching. The previous one was just sketching, just figuring out how to make the first sketches of the problems. Today we're going to sketch and solve it. Okay, so I'm going to look first at problem number 1. I'm going to draw my line. Okay, now once again, when we sketch, what's inside the parentheses here, this 2x plus 1, that's what we're sketching. That's the triangles and the cubes. The number on the outside, this 3, just tells us how many of those sets. So I need to sketch 2 x's and a 1. So remember, x's are our triangles, so I'm going to do 2 triangles. The 1 is a constant. It's a number without a letter or a variable, and that's just going to be a cube. So I'm going to make it 1 cube. That's one set, 2 x's and a 1. Now I need to do 3 of those sets. I have the first set. Here's the second set, 2 triangles and a 1 cube. And here's the third set, 2 triangles and a 1 cube. And that's all equaling a 9, and that's a 9 cube. Now if I kind of want to put these together, and I do, sort of want to, remember we can rearrange or combine on one side. So on this left side, I want to get my triangles together. And I'm just going to do it like this. So I had originally 1, 2, 3, 4, 5, 6, and now I still have 1, 2, 3, 4, 5, 6 triangles. And I'm going to take these 3 1 cubes here, and I'm going to put those together. Remember, you just add them up. So 1, 2, 3, and I'm going to turn that into a 3 cube. You don't have to do this step, but I like to do it. To me, it just sort of consolidates things and makes it a little bit easier. And it's also the combining like terms step. And it also shows the distribution as far as how that would work if you did it algebraically. When you multiply 3 times 2x, 6x, I got 6 triangles, and 3 times 1 is 3, which is the 3 cube. So it does help to show how that distribution comes about. Now coming back to my sketch, I need to get my triangles by themselves. They're all together, so I can't take away triangles. If I'm looking at, I don't have triangles on each side, so I can't mark off triangles. But I do need to get the triangles by themselves, and I notice I have cubes on both sides. So I can take away the cubes since they're on both sides. Always go to the side with the triangles because you want to get them by themselves. So to get these 6 triangles by themselves, I need to take away this 3 cube. But if I take away the 3 cube from that side, I need to take away the 3 cube from the other side. So what I'm left with is my 6 triangles, and then 9 minus 3. And 9 minus 3 happens to be 6, so I get another 6 cube. Now I got to figure out what one triangle might be. Now remember, each of these triangles has to be the same number. So if I think, well, what if they're all a 2? So if I replace them with a 2 and try to add them all up, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12. Well, that's way too big. So I'm going to say, nope, it's not a 2. It needs to be smaller. What if they were all a 1? Okay, 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6. That works. So since that works, I'm going to say that one triangle is equal to 1. That means an x is equal to 1. Now I'm going to check it. I'm going to come over here to the other side. Instead of doing problem number 2, I'm just going to do my check over here. I'm going to re-sketch my original sketch before I combined it. You always want to try to go back to what's the most original. Okay, so now I'm going to check it. I'm going to go back and re-sketch my original sketch with the 3 sets of 2 x's, 2 triangles, plus a 1 cube equals a 9 cube. Always try to go back to what's original. And I'm going to do this instead of doing number 2. And what I'm going to do is I'm going to substitute in for the triangles what I think it equals. I think x equals 1, so that's what I'm going to substitute in there. And when I add up all the left side, it needs to equal a 9. because the two sides are supposed to equal each other and the right side is just a 9. So instead of the triangles, I'm going to replace each one with a nice big 1, so it makes it more obvious. And now I've got the 3 cubes still there, so I'm just going to add them all up. Okay, so and I'm going to mark them as I do it so I know. So 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6, plus 1 is 7, plus 1 is 8, plus 1 is 9. So I get 9 for my left side, and I already know that I had 9 on my right side, and that's equal. I've got the same number on both sides, so that means that my original answer of x equals 1 is correct. Okay, now I'm going to go down and look at examples 3 and examples 4 because they are a little bit more complicated. Okay, so on example 3, once again, I've got this 2x's plus 1, but now I've got 4 sets of them. So I'm going to do my 2x's or 2 triangles in a 1 cube, and I'm just going to make 4 sets of those. Because the number outside the parenthesis tells you how many sets. So that said 4 sets, so I've got 1, 2, 3, 4 of them. On my other side, I also have parentheses, so this is 3x's and a 5. So I'm going to do 3x's and a 5 cube, and this 2 out here tells me I need 2 sets of those. So now I have 1, 2 sets. And now I am going to go ahead and combine them like I did before. I'm going to go back up here and look and count. I've got 1, 2, 3, 4, 5, 6, 7, 8 triangles. So I'm just going to make it with 2 rows of 4 so they're kind of clumped together. That gives me 8. And then I've got 1, 2, 3, 4, 1 cube, 4 cube. And now I've got that side combined. And then on the other side, I've got 1, 2, 3, 4, 5, 6 triangles. So I'm going to do 2 rows of 3, which is the 6. But then the 5 and the 5 cube, I'm going to turn that into a 10 cube. And so now I've got that combined up, and that also helps to show, once again, how the distribution works. Because if you're doing the algebra steps, 4 times 2x would be 8x's, so that's why I should have 8 triangles. And 4 times 1 is 4, that's my 4 cube. And if I do the other side, you do 2 times 3, which is 6, and those are x's. So 6 x's make 6 triangles. And then 2 times 5 is a 10, that's where the 10 cubes comes from. So that's how this sort of correlates or translates to the algebra side of it from the sketching. And now I'm going to go back to the sketching, and I'm going to remember that I can take away triangles from both sides since I have triangles from both sides. But this is one of those things where what you do to one side, you have to do the other. So I notice I can take away, let's say I can take away 2 triangles from the right side, then that means I have to take away 2 triangles from the left side. But I still have triangles left over. In fact, I've got 4 left over on the right side. So I can take all 4 if I want, but then I got to go over to the left side and take away 4 there. As long as you take away the same number. You can do it one at a time or in a group or in one step. Actually, I could have taken away, if I count this right, 1, 2, 3, 4, 5, 6 triangles from the left side, as long as I take away 6 triangles from the right side. That's perfectly fine. You just have to take away the same from both sides. What I've got left is 2 triangles on my left side and the 4 cube. And on my right side, I now just have that 10 cube. Okay. Now I'm going to look at what else can I take away. Well, I need to get the triangles by themselves, and I notice that I've got cubes on both sides. So I need to take away some cubes. Always go to the side where you've got your triangles because you want them by themselves. You want them isolated. So we're going to take away this 4 cube. But if we take away the 4 cube from the left, we need to take away the 4 cube from the right. So what we have is 10 minus 4, which is a 6, or 6 cube, and we got 2 triangles left. So then we need to try to figure out what is 1 triangle. So I need the same number in both places that when you add together equals a 6. So I'm going to try a 3. And 3, and you're adding, 3 plus 3 does equal 6. So I'm going to say that 1 triangle is a 3. That means x is a 3. And I'm going to go over here, and now I'm going to try number 4. Okay, on number 4, I have this distribution here. And I've just got this x plus a 1, and there's no number out in front of the x, so I'm just going to put a 1 there. Always put those there just to remind me. So that's a 1x. So this is what I'm going to be sketching, a 1x and a 1. So one triangle and a 1 cube, and this 3 out here means that I need to do 3 sets. So one triangle and a 1 cube, and one triangle and a 1 cube. And then over here, this 2x means I need to do 2 triangles separately. Because that wasn't a part of the distribution, it was just what comes next. On the right side, I have 4 triangles, 4 x's, and a 4, which is a 4 cube. And now I am going to sort of group them up, because remember, you can rearrange on one side. So I notice that over here on my left side, I've got 1, 2, 3, 4, 5 triangles. So I'm just going to put them all together. And then if I add up all my cubes, I've got 1, 2, 3 cubes. On my right side, I've just got the 4 triangles and the 4 cube. And once again, I like this as a visual because it definitely shows how the distribution works. And then if you think 3 times 1x, that's a 3x, which is where my 3 original triangles came from. And 3 times 1 is 3. Okay, and that's where my 3 cubes came from. But when I combine them, this 2x combines with my 3x. And that's how I have 5 triangles. And then you add up all your 1 cubes and you end up with a 3 cube. So it very nicely shows how the different things also get combined together. Now I'm going to look at keeping on the solving, and I'm going to look at what can I eliminate, what can I take away. Well, I notice I've got triangles on both sides, so as long as I take away the same from both sides. So this time I'm going to do it one at a time. One from the right, one from the left. I can keep going. One from the right, one from the left. I can keep going, and I can keep going again as long as I'm doing one from the right, one from the left. And now I'm kind of done with triangles because I don't have any more on the right. So I've got 1 triangle and the 3 cube. On the right side, I just have the 4 cube. Okay, but remember, now I've got cubes on both sides, so I need to take away some cubes. Always go to the side with the triangle. This side, I'm going to take away that 3 cube. If I take away the 3 cube from the left side, I need to take away the 3 cube from the right side. And 4 minus 3 is 1. And I've just got my 1 triangle left. Since 1 triangle equals an x, that means that x equals 1.